In the last video, I introduced the concept of integration by parts, and in this one I want to do a few more advanced examples. So I'm going to talk about how to take the integral of ln of 6x squared times dx and the integral of e to the 2x times sine 7x, but before I do that, I want to prepare you and give you this tool that's incredibly useful. So there was a guy named Herbert, and I know I'm mispronouncing this, but Herbert Kasube from Bradley University. Gotta give credit where it's due. And he came up with the LIATE method. I'm sure I'm mispronounced that too. But LIATE method is essentially saying that when we have our integral, right? Because when we're given a function, f of x times g prime of x dx, you know, which one are we going to call f of x and which one are we going to call g prime of x? And so the LIATE method gives us a tool for using that. So basically what he says is that you start at the L and you work your way down. So you go LIATE. And so if, for instance, with the ln, or let's use this example here, the e to the 2x times sine 7x. You know, which one is going to be f of x? Which one is going to be g prime of x? What you do is you consult this chart here and you say, well, first, if it's a log, or if it's, you know, if it's inverse trig, or if it's an algebraic function like x to the 30 or x to the 2, if it's trig or if it's exponential functions, whichever one comes first. So you look for the first one. Whichever matches first. That is your f of x. So what we have here is we have our exponential function. You know, e to the 2x is exponential function. And then we have our sine of x, or sine of 7x, and that's a trig function. So according to Herbert Kasube, what you would do is you would say, because the trig is higher up, that one is your f of x. It's a LIATE method. It's pretty easy to remember. Just remember LIATE, and then you remember what each letter stands for, and you'll be well prepared. So let's start on this example here. We're going to do the integral of ln 6x squared times dx. And remember, our integration by parts formula is we have the integral of f of x times g prime of x dx, and this is equal to f of x times g of x minus the integral of f prime of x times g of x dx. Our reverse chain rule. Okay, so according to the LIATE method, well, I mean, we really only have one function in the first place, so we don't need the LIATE method for this one. But we're going to call, we need to call our f of x and f prime of x, and our g prime of x and our g of x. So we'll call f of x, because we don't really have a choice, we'll call that ln of 6x squared, which means that the derivative, I don't have enough space here, I'm going to remove this. So our derivative of this is going to be 2 ln 6x times the derivative of the inside, 1 over x. And so then we have our g prime of x is going to equal dx, and that just equals 1, because the derivative of x is just 1. And then our g of x is going to be the antiderivative of 1, which is just x. So what we do is we just plug these values into the formula, but maybe it'll work out, maybe it won't. We'll find out. So we take ln of 6x squared, or ln squared of 6x, I should say to be more correct, times times x, because we're timesing it by g of x, f of x times g of x. And we subtract that by the integral f prime of x, so 2 ln 6x times 1 over x, and we multiply that by g of x, by x. So as we can see here, the x's will cancel out, and that will just equal 1. And then we are left with ln squared of 6x times x minus the integral 2 ln 6x. We can factor out the 2, but really we're still at, we still have to take the integral of ln of 6x. Oh, I should put dx here, times dx to be very correct. So really this doesn't help us. We still can't immediately calculate the integral of ln of x, so we use integration by parts twice. What we do is we say we have this, but now we're going to use integration by parts on this half again. And so what happens here is we're going to say we have negative 2 times, and now we're going to use integration by parts here. So we need a new f of x. We need a new f prime of x. We need another g prime of x and g of x. So what do? So we say our f of x is going to be ln 6x. So it's going to be ln of 6x. But as you can see, it's not squared anymore. So we just do it twice and hopefully it'll work out again. And then our f prime of x is just 1 over x. Our g prime of x is still dx, so that just equals 1. And our g of x equals x. So let's plug this in and see how far we can go. So we do f of x times g of x, so then we get ln of 6x times x. We subtract that by the integral of f prime of x, which is 1 over x, times x. And of course, this is times dx, and this is all within these brackets, because we still have ln squared of 6x times x minus 2 times this. Okay, so it gets a bit harder, as you can see, but we've simplified it so that we are just taking, the integral of 1, because these cancel and make 1. So we go ln squared of 6x times x minus, now we're going to factor these in, so negative 2 ln 6x times x. We subtract that by, now what is the antiderivative of 1? It's just going to be x. But since we have to times that by negative 2, then it becomes plus x. Plus 2x. Yes, okay, so plus 2x. So then we can factor this out and we can say, okay, so all of them have a common x. And so we just factor this out, so it's x times ln squared of 6x minus 2 ln 6x plus 2. Well, I should say, and I think I've forgotten this entire last video, yeah, plus 2 plus c. Don't forget the plus c. I always do. And this equals, of course, the antiderivative of ln squared of 6x times dx. So as you can see, sometimes we have to use integration by parts twice. And now, the other example I wanted to do, we have the integral e to the 2x times sine 7x dx. And now, using the LIATE method, I can see that the trig functions are higher up than the exponential functions. So we have the trig function, it's higher up than the exponential function, therefore whichever matches first is f of x. So we know that our trig function is going to be f of x. So we write f of x and f prime of x, and f of x is equals sine 7x, and f prime of x equals cos 7x times 7. And then our g prime of x has to be our exponential function, so e to the 2x, which means that the antiderivative of that equals e to the 2x divided by 2. So let's plug this into our integration by parts formula, which means that we will get, I'll just rewrite this here, e to the 2x. is is equal to f of x times g of x, so sine 7x times g of x, so e to the 2x, divide this whole thing by 2, and we subtract the integral cos 7x times 7 times e to the 2x divided by 2. And so we can factor out these constants, 7 and 2, and then we just get, so we're factoring out 7 divided by 2, and then we're timesing that by e to the 2x. And now, it doesn't appear that we're any closer than where we started, so we can integrate again, integrate by parts. And so we need our new f of x and our new g of x. So our new f of x is equal to cos 7x, which means that our derivative of that is going to be negative sine 7x times 7. And so our g of x, or g prime of x, is equal to e to the 2x, which means, again, nothing changed. We have e to the 2x divided by 2. So that's our new f of x and our new g prime of x. Let's plug this in again. We have sine 7x times e to the 2x divided by 2 minus 7 over 2. And now we integrate by parts again. So we have our, whoops, I'll do this in a different color here. So we have our cos f of x times g of x, cos 7x, times e to the 2x divided by 2. Subtract that by the integral of negative sine 7x times 7 times e to the 2x over 2. And this is all enclosed within these brackets. So just as we did with the previous equation, we have two constants. So we'll factor out negative 2 and 7. And so we'll get negative 7 over 2 times e to the 2x. Now, when I saw this, when I first did this question, I was amazed. And when I found out the solution, I was literally jumping up and down, because what we have here is negative sine 7x times e to the 2x. Well, I should put dx here. But our actual integral that we're trying to solve is the exact same thing. So what if we could just move this over to the side of the equation? We might be able to solve the integral that way. But first we have to simplify. So this equals sine 7x times e to the 2x divided by 2 minus, now I'm going to factor these out, the 7 divided by 2, so 7 over 2 cos 7x. But since it's divided by 2 here, this is actually negative 7 divided by 4. So cos 7x times e to the 2x. And then we minus, so now we have negative 7 over 2 times negative 7 over 2. So that means we plus 49 over 4 times the integral of negative sine 7x times e to the 2x dx. And now, since we have a negative sign here, this is the same thing as negative 1 times sine. So we can factor this out, and this becomes a negative if we just factor this out. So now we have negative 49 over 4. And as you can see here, the sine 7x is the exact same as our original equation. Now, I'll just rewrite this here. E to the 2x times sine 7x times dx. A lot of writing. Now, let's just multiply everything by 4. And we'll get rid of these 4's here, this 4 here, and get rid of the 2, and we end up multiplying it by 2, and we have a 4 here. So what we're going to do, since we got rid of these 4s, just by multiplying everything by 4, we're going to plus 49 times the integral of sine 7x. So we're going to bring this over to this side of the equation. We're adding it, which means that we're going to have 49 plus 4, so we get 53 e to the 2x times sine 7x times dx is equal to 2 sine 7x times e to the 2x minus 7 cos 7x times e to the 2x. So now we put it in terms of the original equation. We can just divide by 53. Divide by 53. Divide by 53. Divide by 53. And we've solved it. We've solved this problem, and we could even simplify it further if we want. Because we've essentially said now that it's 53 over 53, we can do that, just cancels. So we have our integral is equal to this. And I think that was crazy. I never would have thought of that if I hadn't looked at a solution manual. So this means, since they both have common e to the 2x's, we can just factor them out. So we have e to the 2x divided by 53 times sine 7x times, well, don't need to times it, minus 7 cos 7x. And there you have it. That's the solution to that integral. But there's something more important than this. There's something crazy. There's a general formula for this. For instance, we started out with the equation e to the 2x times sine 7x dx. That was our original integral. However, this 7x is completely arbitrary. It's a constant. Why don't we just call that, instead of 7, we'll call that ax. And the 2 in front of the e to the x, why does it have to be 2? We'll just call that bx. And so what this means is that the general formula, well, actually, okay, to be with convention, I'll reverse these. So this will be e to the ax times sine bx. Then there's actually a general formula for this. For instance, we used 7 here. We had the 7 as our b. And we had 2 as our a. Whoops, sorry, this was times 2 for here. That was a mistake. So we have that there. Now we have, so we see our 2 here, and we also see our 2 here, and we also have 2. So I'm not going to prove this mathematically, but I will define this, which means that if we are ever given if you're ever given an integral that looks like this, then what you can do is you say e to the ax divided by, I mean, look, what's this 53 here? Well, what's 7 squared plus 2 squared? That's 49 plus 4. So that's 53. And so since 7 was our b, we could say that this is over b squared plus a squared. And since this, I mean, this is the same, which I'll use the same color, times, and since that the 2 here correlates with the ax, so we would say times a sine, and b was our number inside, times bx, I should have chosen a different color, minus, and since 7 was here, so we minus b cos bx. So this is the general formula. if you're ever given e to the ax times sine bx times dx, then that is equal to e to the ax over b squared plus a squared times a sine bx minus b cos bx. And this also works for cos. Now, I haven't proven this. I'm just defining it. But for cos, if we have the integral e to the ax times sine, or sorry, times cos, because I'm talking about cos, times cos bx dx, then I'm defining this to be e to the ax over b squared plus a squared. It's very similar, except that we have b sine bx plus a cos bx. And so that's a general formula. So that's why I wanted to go through this question, and then you can see that general formula for yourself.